So in the previous session, I have covered one of the important approach in order to generate the word vectors or word embeddings. That is the probabilistic based approach. So in this session, I am going to explain you one of the most popular and widely used word embedding reduced out of probabilistic based approach or a skipgram based approach. That is Word2Vec embedding. So first, let us know what Word2Vec is like. So Word2Vec is a technique used to compute the word embeddings or word vectors using a large corpus of the training data. So even the skipgram model we used to generate the word vectors, right? So the let me explain the structure how this Word2Vec or where this Word2Vec sits on. So this Word2Vec is generally built on the skipgram model approach, and the skipgram model is a example of probabilistic based approach. So basically, this Word2Vec is a example or a embedding built on top of probabilistic based approach. So suppose like you have a large corpus of vocabulary, 10,000 words. So we have a large like number, many number of sentences, and I have broken those sentences into 10,000 words. Then the task is to create a word embedding, say dimension of 300 for each word. Then each word should be a vector of size 300. That is a 300 dimensional space, right? So the very first step is to create the distributed representation of the corpus using a technique such as skipgram, right? So what I mentioned before is like this Word2Vec is built on the skipgram approach, and the skipgram approach is a probabilistic based technique, right? So that's what the final conclusions of what I could say. So skipgram, where each word is used to predict the neighboring context words, right? So in the probabilistic approach as well, what we used to do, suppose if we pass a word as an input, so word as an input, we used to get the context words or the like neighboring words for the given input word. So with this same basic idea, even this Word2Vec is or Word2Vec embedding is built. But this is for a smaller example, that skipgram approach or a skipgram method is for a smaller set of words. But this Word2Vec embedding is for a larger data set or a larger text corpora. Okay, so the basic intuition of this Word2Vec is to the models that is a shallow neural network which we use here is to learn to predict the context words correctly for each input word. The input to the network is a one hot encoded vector representing one term. Example, the figure which I showed here. So in order to understand it in a better way or say for a larger corpus of text, I will be explaining the whole concept of Word2Vec using this following diagram. So, given a large input vector or a input corpus of words, so say 10,000 words. Suppose if I want to train this entire neural network, then what I used to do, so I have to convert the input vector or input data into one hot encoded vector, right? So here currently I have taken the word ants. Okay, so ants is a word which I am going to pass it to the shallow neural network which I have created. So for that the input vector will be like so 0 in all the every position, all the 10,000 positions except where this ant word is present. Okay, so now I will pass this input vector to the hidden layer. So as I mentioned, like I'm just reducing this 10,000 set of words into 300 dimension word, right? So I'm creating an embedding of size 300. Okay. So that's why the size, the final size of the word embedding is basically dependent on the hidden layer, right? So the hidden layer is the most critical layer where the weights associated with each terms are captured, or the basically we remove this hidden layer and use it as a word embedding. So that's what we like learned in the previous sessions, right? So So each of the input vector coming from the input will be connected to each of the 300 neurons present in the hidden layer. So it will be connected to each and every neuron, that is each 300 neurons present in the hidden layer. And this output or the this layer will further pass the signals to the final output layer, what we generally called as a softmax layer or a softmax function, where it will aggregate the signals coming from the different neuron, and it will be same as a input size, or the size of the output layer should be same as the input vector, right? So it will be generating the contextual words, like related contextual words or the neighboring words for the word and. So generally the size would be like it is also 3000 cross sorry, it will be 10,000 cross 10,000 size. Even the output layer would also be the 10,000 cross 10,000, but the difference is the output we will be having a contextual words, right? So here based on some large corporate text like say 10,000 positions, so we got the output as ability, able, and zone has as a different contextual or the neighboring words for the word and. So what we will do, we have to train this until and unless we get a proper contextual words. So we have to pass this different set of sentences or different set of words again and again to this whole neural network in order to train this complete hidden layer, in order to understand the weights associated with each of the word.